All right, so we're to determine the exact total surface area of this figure. The height is 24 centimeters. So it's like a cylinder with a piece cut out to the center. Okay, so and the height is 24 centimeters. So that's the height that it connects the two congruent and parallel bases. So that's 24. The radius is 18. Okay, so the radius of that, the cylindrical base, if you will, the cylinder with the piece cut out is 18, and the angle of the slice removed is 80 degrees. Okay, so we have to kind of get comfortable with the different surfaces that we're looking. So if we want total surface area, we need to figure out the surfaces we have. Well, on the top we have like this circle with a sector cut out of it, so it kind of looks like a mouth of Mr. or Mrs. Pac-Man, right? But that also duplicates on the bottom. Right, so there's two of those faces, right? Then there's that rectangular lateral face that wraps around like a soup can, like label of a soup can. So there's like that rectangular face that wraps all the way around this thing. Right? But then we can't forget about these rectangular faces. Like if you cut out of like a circular or cylindrical like cheese wedge, you're gonna get rectangular faces. So there's a rectangle here and there's a rectangle here, and they're two congruent rectangles. The two congruent rectangles are 18 by 24. So if I come up with like a plan of attack for this problem and I want to get the total surface area, we have to be aware of the surface that we have. So we have two congruent rectangles plus two congruent, call these sectors of a circle, so two congruent sectors. That's the Pac-Man face. And then we have the lateral area of the cylinder. So if we could get those areas, if we add them together, we have the total surface area of the figure. So let's start with the two congruent rectangles. The two congruent rectangles, they are sometimes hard to spot, but then when we see them, we're like, oh, it's pretty obvious, and they're 18 by 24. So the two congruent rectangles, we have two rectangles that are 18 by 24. Right, so if we take 36 by 24, we're at 864. So the area of the congruent, two congruent rectangles is 864 centimeters squared. Okay, let's switch colors here. Let's get the two congruent sectors. So we have two congruent sectors. It told us in the problem that there was an 80 degree kind of slice cut out of this. So we have this circle, portion of a circle, most of this circle, we have like 80 degrees kind of removed from it, from the center. Okay, so there's our circle. We have a radius of 18. We have this 80 degree wedge cut out of it. Well, if 80 degrees is cut out of it, that means 280 is left in it, right? Because the full circle is 360 degrees. So I'm gonna think about it that way. I have 280 degrees of the 360 degree circle. So when you get the area of a sector, you take the portion of the circle you have and you multiply it by the area of that particular circle, which would be 18 squared times pi. We have to remember there's two of those sectors, so that we have to double that, right? So we could do 280 divided by 360. We can multiply that by 18 squared. We could double that, and we're at 504 pi. So the area of the two sectors is 504 pi centimeters squared. Okay, the last thing that we have to calculate, I'll switch colors one last time, is the lateral area of the I'll use red because it's in there, it's red. So the lateral area, so step 3, we want to determine the lateral area of the cylinder. Well, if we remember, like a cylinder, the lateral area is like a label of a can of soup. And if you take off the label of a can of soup and you flatten it, it's going to be a rectangle. Okay, the rectangle that we have has the height of the cylinder, which is 24, but then the length of the rectangle, right, is the circumference of the bottom circle. But we have to understand that we have a portion of that circle missing. So for us, it's kind of like this arc length formula. So we have this lateral cylinder. When the lateral area of the cylinder, the lateral area of the cylinder is going to be a rectangle when we flatten it out. Its height is 24, but its base is typically the circumference of the circular base, but we don't have a full circle base. We have portion of a circle. Essentially, we have an arc length. So we have to determine that base by doing a arc length formula. We have 280 degrees of the full 360 of the circle multiplied by the entire circumference, which would be 2 pi r, which would be 36 pi. Right? Well,